Hey Stats class, we're looking at a hypothesis test about a mean, and we're given a sample size, and down here we're given the statistics from the sample. So the null is the mean is 50, the alternate is the mean is less than 50, so this is a left-tailed test. All right, we want to know what is the test statistic. So to remember, to get the test statistic, all you're doing is a z-score, but because we're using S with sample means, it's actually a t-score. But it's the same concept. It's a measurement, which in this case is the sample mean. So I'm going to use the 46.5 minus the population mean. So that's the 50 here. And I'm going to divide by, I'm going to do another fraction. S, which is 13.3, divided by the square root, SQRT, of our sample size. Sample size is 25, so I'll put a 25 there. So there is my test statistic. It wants it to 3 decimal places this time. So negative 1.316 would be my test statistic. All right, after we get the test statistic, they tested at the 0.05 level of significance, and they want us to come up with the critical values there. So I'm going to down here, click on another one, open up this is a t-distribution because it's about mean. So t-dist, open up parentheses, tell it the number of degrees of freedom you have. So the sample size is 25, so this is 24 degrees of freedom. Right? I'm going to click this because this is a left-tailed test. Okay, because we're saying the mean is less than for our alternate hypothesis. We're going to click left. Right? And anytime that you're wanting a critical value, you're going to select bounds. Okay, what do I want the area in the left tail to be? It's a left tail test. I want alpha to be in that. So instead of 0.5, I want 0.05. All right, so there's my shaded region. There's my critical values. So I can click it down here. There's the number. 3 decimal places would be 711. So negative 1.711. All right, and then after you get your critical value, it wants me to draw a t-distribution that depicts the critical region. And you're not having to draw it, you're just having to pick which one it is. So it's a left-tailed test, so it's going to be the one on the left tail. It's also going to be the one that's going to match your picture from Desmos over here. So the one that's shaded in the left tail, so that's it, which is A. Okay. The other one is a right-tailed test beside it, and then a two-tailed test. Notice alpha gets cut in half when we do a two-tailed test. All right, then we want to know, will the researcher reject the null hypothesis or not? So the way that Desmos can help you with this, when you do it this way, when you have to get the critical values, just plot the test statistic. So this is our test statistic right here. I'm going to copy that, and then just make a point. A point is just an ordered pair, like from algebra, where the x-coordinate is the test statistic and the y-coordinate is 0. So in this ordered pair right here, I'm going to just paste, that's my test statistic, and then comma 0, and I can see that's where I am. I didn't quite fall into the rejection region. So since I didn't fall in the rejection region, I'm going to fail to reject. So will the researcher reject the null hypothesis? No, because the test statistic does not fall in the critical region. So there's our answer.